Here we're going to draw the Lewis structure for the nitrate polyatomic ion. And this is going to illustrate two concepts. One, how to deal with a polyatomic ion with a Lewis structure, given that polyatomic ions have picked up or lost extra electrons. And two, the concept of resonance. So let's get started with our nitrate Lewis structure. First thing we're going to do, we're going to list out our once and has. So we've got one nitrogen, 1, 2, 3 oxygens, and then we'll take into account our extra electrons. So here we go, we've got have and want to have. Nitrogen has 5, looking at the periodic table and counting from the left side to the right, wants 8. Oxygen has 6 and wants 8. Fill in the table the rest of the way. Now we've got an extra electron coming from the charge here of the polyatomic ion, which means we've got one more electron than we're supposed to. So we just put in one electron, and then we put a dash here. We can now go through and total up our total number of electrons. Ideally, we'd have 32. In reality, we've got 24. Figure out how many bonds we need. 32 minus 24. Gives us 8 electrons to be shared. And remember, it takes 2 electrons per bond. So we need a grand total of 4 bonds. There we go. Now, got to pick a central element for our nitrate polyatomic ion. So remember the rule, pick the least electronegative element, in this case, nitrogen. So we'll start off with a nitrogen surrounded by 3 oxygens. That's going to take 3 bonds, and now we have to make a decision to place a 4th one. I'm going to start off by placing that 4th one right there. And now we go in and fill in lone pairs. Remember, lone pairs go on the most electronegative elements first, so in this case they'll go on oxygen. So we got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we're all out of electrons. If you count them all up, we've used 24 electrons. To indicate this is a polyatomic ion, I'm going to put a bracket and a minus sign out there. And now we're ready to go through and look at formal charge. So, formal charge, valence electrons for oxygen is 6. Minus the number of bonds there, 2 plus 4 electrons means that this oxygen has no formal charge, so this is starting to look good. Let's do the next oxygen. Well, we'll do this guy right here. 6 valence minus this one has 1 bond and 6 electrons, meaning we've got a minus 1 charge for this particular oxygen. So minus 1 formal charge here. And because this oxygen right here is the same, we've got 2 oxygens with a minus 1 formal charge. So things are starting to not look so ideal now. Let's take a look at nitrogen. Nitrogen, we'll do it over here. Nitrogen has 5 valence electrons normally. It's got 4 bonds attached to it, plus no electrons, meaning it has a plus 1 formal charge. So we've got 3 atoms with formal charges on them. 2 oxygens with minus 1. And oxygen's okay with that being more electronegative. It wants to have the extra electron, or is better equipped to deal with an extra electron. And the nitrogen has a positive 1, which just has to be because nitrogen can't physically have more than 8 electrons around it, and all those electrons are tied up in bonds. Well, maybe there's a better structure than this one to identify the nitrate ion's Lewis structure, so let's try a different form. So again, we're going to start off by putting nitrogen surrounded by 3 oxygens, and this time I'm going to put the double bond over here and fill in my lone pairs on my oxygens. And what we see is we essentially have an identical structure to the first one. Rather than the double bond being on the left oxygen, now it's on the right. Still going to have the same problem of formal charge. In fact, they're both identical. 2 oxygens with -1, the central nitrogen with the +1, so things really haven't gotten any better. But we have 2 Lewis structures with the same number of formal charges, with the only difference being where the double bond is placed. In this case, both Lewis structures are considered correct, and this is because we have a concept of resonance. This is where electrons are free to move around because the double bond can be placed in any one of these 3 locations, either here, here, or here. So what effectively happens is you get this nitrogen double bond simultaneously existing in all 3 spots, meaning that the electrons there are delocalized. That is, they're free to move around the whole polyatomic ion. So these electrons in the double bond are mobile. They're not trapped between 2 atoms like they would be in a single bond. So this resonance concept helps share the burden of these extra formal charges on oxygen by basically playing a game of hot potato. Somebody gets an extra electron and it gets bounced back and forth either on this oxygen, maybe it passes it off to this oxygen, which passes it off to this oxygen, and then it passes it back over here, and it continuously does this so that it helps stabilize the actual ion by sharing the burden of having the extra electron, if you will, spread out over all the atoms in the Lewis structure. So here we've got an example of a resonance structure. And you can only have resonance structures when you have double bonds, and double bonds that can be placed in different locations, keeping the same overall connectivity of atoms.